Good afternoon, students. Today we can see the topic SR Flipflop using NOR gate. So already we have discussed about the SR Flipflop using NAND gate. This SR Flipflop using NOR gate, how to design and its truth table, its operation, characteristic equation, then the excitation table we are going to see today. Okay. So this SR flip-flop, there are how many inputs we have? The SR flip-flop is having three inputs. What are the three inputs? One is this S input, then the R input, then the clock input. So the clock should be always it should be high to activate your this flip-flop. And the two outputs are Qn plus 1 and Qn plus 1 bar. So how to define SR flip-flop? It's a sequential circuit which has three inputs, set input, reset input, and clock input. So and it consists of two outputs. One is the normal output Qn plus 1 and a complement output Qn plus 1 bar. So this is the logic symbol which represents the inputs as well as the outputs. So these three are the inputs. These are the inputs and these two are the outputs. So while designing using NOR gate, you have so this first using this NOR gate we have seen in this logic diagram. So you have this present state Qn and Qn bar are given as fed as input to this NOR gate. So this forms this SR latch using NOR gate. So this is SR latch using NOR gate. And for implementation with the clock signal means it forms as a flip-flop. The input to be given to the AND gate. The first one should be the R input and the second one should be the S input. So in the NAND gate, you will be having the S input in the top and R input in the bottom. But here you have R input in the top and S input in the bottom. Okay. So we can discuss one by one. So we have to discuss about these are the topics you have to discuss. The operation, then the truth table you have to discuss. Then you have to discuss about your characteristic table. Then the characteristic equation. Then the excitation table. These are the things you have to discuss. So all these will be forming the same as your SR flip-flop using NAND gate. Only the operation and truth table, the answer should be same, but the operation should be different somewhat. Okay. So we can discuss one by one. So first we can discuss about the operation with the help of the truth table. So while the truth table has the inputs clock signal, S input as well as the R input. Based on the operation, we can see one by one. Okay. So first is, what are the inputs you need? So we need the inputs. What are the inputs? Clock, R, S, and then you need the inputs. S, R, then the outputs. Qn plus 1, Qn plus 1 bar. So these are the things you need to have in the input. So first, you consider the clock should be 0. Whatever may be the input to S and R, your output should be the present state. So it is Qn bar. Now you have to give the clock signal to be 1. And for the clock signal to be 1, we have how many conditions for your 2-bit combination? We have 4 inputs. So what are the 4 inputs? 0, 0, 0, 1, 1, 0, 1, 1. Okay. 0, 0, 0, 1, 1, 0, 1, 1 with clock input 1. Okay. Now we can explain with this operation when first case when r equal to 0, s equal to 0. When r equal to 0 and s equal to 0, what is your input here? Clock is 1, always 1, r is 0 and s is 0. Okay. So the product is 0. With respect to 0 means the AND gate output should be definitely going to be 0. So here also it is 0. So what is your input here? Q1 bar. So what about Q1 plus 1? It is a NOR gate. It is complement of OR. So 0 plus Q1 bar the whole bar. What is 0 plus Q1 bar the whole bar? Q1 double bar. So it is 2n. So the output is now the present state. Now because we don't have the value, we have to check for the other condition. Q1 plus 1 bar. What is Q1 plus 1 bar? Which is equal to the input to one NOR gate is 0 and another one is Q1. So 0 plus Qn the whole bar. So what is 0 plus Qn the whole bar? Qn bar. Okay. So what is the output you are getting? One is Qn and another one is Qn bar. So here it is Qn and Qn bar as in the case of your NAND gate. Okay. The second thing is when s equal to 0 and r equal to 1. So this is case 1 and the case 2 is when s equal to 0 and r equal to 1 or r equal to 0 or any one case we can check. So what about your Qn plus 1? So now you come to the condition s equal to 0 and r equal to 0. So this will be r is 1. So we can erase all these. So now the condition is r equal to 1 and s equal to 0. When r equal to 1, so 1 into 1 becomes, here the input is 1. And 1 into 0 becomes, the input is 0. So what about Qn plus 1? Qn plus 1 is equal to Qn bar plus 1 the whole bar. So 1 plus Qn bar. What is 1 plus Qn bar? It is, what is 1 plus Qn bar? It is 1. So it is 1 bar, it is 0. So if you are getting the value to be 0, definitely Qn plus 1 bar should be 1. So what is the output here? It is 0, 1. Okay. Next we have the condition S is equal to 1 and R equal to 0. Okay. So when now S equal to 1 and R equal to 0. So when S equal to 1 and R equal to 0. So when S equal to 1, R equal to 0, the output for the first AND gate should be 0 and here the output is 1. So the third case is when S equal to 1, R equal to 0. What about Qn plus 1? Qn plus 1 is equal to, so 0 into, so Q1 plus 1 becomes, it is 0 plus the Qn bar, the whole bar. So 0 plus Qn bar, the whole bar becomes Qn bar bar. So it is Qn. Now you don't get any value. So you have to check for the next condition, Qn plus 1 bar. Q1 plus 1 bar is 1 plus Qn the whole bar. What is 1 plus Qn? It is 1 bar. So it is nothing but 0. Now you are getting the Qn plus 1 bar. The complemented output is 0. So definitely, then what should be the present state? It is Qn plus 1 is 1. Okay, it's complement. So what you'll be getting for here in the our truth table, you have 1 here and it is 0. Okay, next comes to the fourth case when Q1 when S equal to 1 and R equal to 1. In this case, when S is equal to 1, R equal to 1, now your output here becomes, sorry, input becomes, here R is 1. So here it is R equal to 1. R is 1. So R is 1, 1 is 1 means definitely it is not 0, it is 1. So when R is equal to 1, here also it is 1. So both of having the input to be 1. Okay. So when S is equal to 1, now the input to the latches are 1. Okay. What is Q1 plus 1? 1 plus Qn plus 1 bar, the whole bar. So what is Qn plus 1? 1 plus Qn bar, the whole bar. 1 plus Qn bar is, it is 1 bar, which is 0. Now, because since the input to this latch, both the inputs are 1. Till now, which we have discussed, we don't have the value to be one same. One is opposite. Okay. So we have to check for the next condition also because of this. So Qn plus 1 bar is equal to, now it is 1 plus Qn the whole bar. So what is, it becomes 1 bar. What is 1 bar? It is again 0. You are getting both the output to be 0. Definitely, Q1 plus 1 is 0 means it is Q1 plus 1 bar should be 1. So, but we are getting the both the state, it should be 1. So, it should be a not existing or an invalid state. So, when this, while checking this truth table, you are getting, this is the truth table for this SR Flipflop. You are getting the same truth table. Only the thing is you have to explain with the operation. It is different. So when when your clock is 0, present state. So now when clock is 1, for 0, 0, it is the no change state you are having. And for the next, when S is 0 and R is 1, you have the 0 output. So it is nothing but the reset state. And when S is equal to 1 and R equal to 0, you have the set state. And the last state is nothing but the forbidden state, or it is called as an invalid state. Okay. So this is the operation of SR flip-flop. Next, we can move on to the characteristic table. So characteristic table has, what are the inputs to the characteristic tables? The input to the characteristic table are Qn, then set input and the reset input. And the output is Qn plus 1. Okay. So it is, we have a input to be 3 inputs, right? So it is Qn, Qn, yes, R, and Qn plus 1 is output. So since it is a 3-bit combination, we have 0, 0, 0 to 1, 1, 1. Zero, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So now come to this Qn plus 1. What is Qn plus 1? Qn plus 1, see this truth table and you can write it. For 0, 0, you have the present state. Now the present state for is Qn is, what is the present state now? As per your truth table, the present state is Qn is 0. So what is your output then? It is nothing but 0. Now come to the condition 0, 1. 0, 1 means it is reset state. What is the output? You have the output 0. Then comes to 0, 1, 0. What is your output? It is nothing but a set state. Your output is, next state is 1. Okay. Now come to the 0, 1, 1. We don't have any output. So it is the don't care state. Now come to the 0, 0. Now what is your present state? Your present state is 1, right? So your output next state should be 1. 0, 1 means it is 0. 1, 0 means 1, 1. 1, 1 means don't care as per your which table? The truth table. So based on the operation, we have given the characteristic table, and from this we can form the characteristic equation. So what is the characteristic equation? First we have to formulate the min terms for this next state. What is the min terms you have? It is the min terms are corresponding to 1, it is 2. Then 1, 0 corresponds to 4. Then 1, 1, 0 corresponds to 6. And we have the 2 don't care condition, which is corresponding to 3 and 7. Okay. So summation m of 2, 4, 6. So based on this, we have to formulate the 3 variable K map. In the 3 variable K map, how many inputs are there? You have 3 inputs. So what are the inputs? You have Qn, S, R, 0, 0, 0, 1, 1, 0, 1, 1. Sorry, 1, 1, 1, 0. Then 0, 1. The min terms for which it is having 2 forces. So 2 is this position. 4 is this position and 6. 3 and 7 are don't care. Remaining all are 0. How to group this? We can group this 4, and for this one we can group like this, right? So 2 groupings are there. What is your next state equation for the using the K map? For the 4 grouping, you will be getting only yes, because these 2, 0, 1 complemented. And here, this 1 and 0 gets complemented. You will be having this 1, which is corresponds to yes. Then plus, this one corresponds to Qn bar. So it is Qn bar. And corresponding to this, you will be getting this column and this column. So these 2 will be there. So what is this corresponds to? R bar. Sorry, Qn R bar. Not Qn bar, it is Qn R bar. This is 1, right? So this is your characteristic equation. So from this we have to formulate the excitation table. What is the excitation table? So the excitation table, what are the inputs? It is the present state Qn and the next state Qn plus 1. And what are the outputs you are having? S and R. So based on this table, you have to formulate this excitation table. So what are the Qn, sorry, Qn plus 1 are the inputs, S and R are the outputs. S and R are the outputs. So 2-bit combination means 0, 0, 0, 1, 1, 0, 1, 1. Now come to this table, this characteristic table. From this, what are the 2 states you are having? Qn 0, 0. Okay. So you check this. You are having how many cases 0, 0? So in this, you have this is 0, the present state 0, next state 0. This also 0, 0. But what about the S and R input? This is 0, but here you have 0, 1. That means you have one condition 0 and another condition 1. So what is your output here? S is 0 and this is don't care. Okay. Next corresponds to present state 0. Present state 0. and the next state should be 1. So what is your present state 0? Present state 0 corresponds to Q1, the third row. 0, 1. 0, 1 means what is your output? 1, 0. So here you have 0, then is present state 1. So what are the things you can have here? So it is nothing but 1, 0. Then for the 1, 0, definitely it is 0, 1. Then comes to 1, 1. 1, 1 corresponds to corresponding to 1, 1. 1, 1. We have the fifth row 1, 0, 0, and in next state 1. And next we have 1, 1, 0, next state 1. So you can have this. So you refer your characteristic table. You have the 2 columns. What are the 2 columns? So here it is 1, 1. Okay. Next here it is 1, 1. So what happens? 1, 1. See this S input 0, 1. But see the R input 0, 0. So 0 S input is 0, 1 means definitely it is going to be, don't care here, it is 0. So this is your, based on this you have formulated your SR flip-flop. But SR flip-flop is having this disadvantage of having the forbidden state. That is nothing but an invalid state. Okay. So SR flip-flop using NOR gate we have seen. So you should focus on the logic symbol, in definition, logic symbol, then the circuit diagram, its operation with the truth table, and then the characteristic table as well as your excitation table. Hope you have understand. Thank you, students.